Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan. And today I'm joined by Mark Swanson. He's been newly appointed as the CEO of a company called Aeromine. It's a company that is developing an innovative rooftop wind system. Very interesting stuff. Mark has a distinguished career in solar and distributed energy at SunPower, at Complete Solaria, and at Borrego Solar Systems. Really happy to have Mark on the podcast today. Hey, Mark, how are you doing today?
Oh, I'm doing great. Thanks for having me. It's great.
Yeah, welcome. Glad to have you on the podcast. And I think you just told me that you're actually in Lake Tahoe right now. Is that right?
That's right. Yeah, in the middle of a snowstorm.
And what a beautiful place to be.
Yeah, I love it.
How many years have you been there?
We've been here for 5 years. My wife and I moved up here just before COVID. We had a leased house. And then when COVID hit, we were like, oh, let's just live here full time. So we bought a house and we've lived here since.
What a great place to be. Well, yeah. Now let's shift gears completely and move to your profession. And congratulations on your new role with, is it Aeromine? Am I pronouncing that? Aeromine. And you've just been made the CEO. Well, I guess how long have you been there now?
Let's see. This will be the 15th day.
Oh, yeah. Congratulations are very much.
Thank you.
Are very much in order. But you can do that job from Tahoe?
Well, I can. The team, the business model, the sales model really is worldwide. And so we've got folks all throughout Europe and in the U.S. And the R&D is done here in the U.S. But so, yeah, it doesn't seem to be a problem, although I have been on the road a lot.
Yeah, I would think. So, what is the first order of business as you get into the job? I mean, I guess getting to know everybody and getting familiar with current operations, but I know you're there to take this company to scale. I mean, that's the mission at hand, right?
Yeah, really, I had the opportunity to just step in and start to immediately put that plan together. The good folks that are investing in the business are really excited about taking the business to the next level. We've been in kind of a technology development sort of market opening phase, and they're very excited about being able to expand the business and bring it to market in a serious way. And so my first order of business was really to put the leadership team together in a room and start to hash out a plan. What's that going to look like? How are we going to do this? What do we need? And so we just finished a 3-day workshop working on that. And we're just actually this morning had a call with one of the investors to try and figure out, okay, how do we take this forward?
How exciting! Well, let's not let our listeners be in suspense any longer about what Aeromine does.
Sure.
I was fascinated that you have come up with, or the founders of your company came up with a technology that is harvesting the flow of wind over a building. And you're somehow collecting that, and I am familiar with some parapet wind systems, but this technology that you have is interesting. That it kind of creates sort of almost a vacuum. You sort of channel the flow, and then it creates a vacuum, and then you're through that vacuum flow, then you are generating power.
Yeah, that's right. The distributed wind business has had a lot of false starts over the years. And I haven't been in the business. As we get into my background, you'll see that I come from the solar industry.
Yeah, you're a solar guy. I can see.
Yeah, I'm a solar guy. Yeah. So, but the distributed wind business, putting small behind the meter wind generators in the built environment has really not been a significant part of the energy mix, obviously, and it's been a difficult place for businesses. But the reason for that is because that wind technology is sort of fundamentally not suitable for the built environment by many estimations. So coming into this, I realized that the wind technology that's out there has problems, all kinds of problems. If you put it on a roof, it vibrates. It makes the building kind of hum. It creates noise. If you ever walked by a distributed, small wind turbine, it makes a lot of noise. It can throw ice. It can create, you can have all kinds of permitting issues. There's all kinds of restrictions in various HJs about how you permit small wind generation systems in the built environment. This system gets around all those problems. It really does. And so that's the thing that got me really excited about it. And I think that's the thing that that your listeners should really organize or concentrate on, is that it solves the problems that have prevented deploying distributed wind generation assets into the built environment. And it does that because it doesn't have any exposed blades. It doesn't have any exposed moving surfaces. And the way that works is it uses a Venturi effect to accelerate the wind through a narrow area. And in the middle of that area is a manifold, an air manifold that is connected to what it would look like to the uninitiated, just a standard building fan, a big for an industrial building,
like an exhaust fan. Yeah,
an exhaust fan. So it's just pulling air through this specially designed exhaust fan, and this Venturi, therefore, is able to dramatically accelerate the air through that exhaust fan, and so that all the moving parts are totally confined. The exhaust fan is relatively small in diameter. It's extremely well balanced. You don't get any noise, vibration, and harshness in the building. And it, from a permitting standpoint, is a much easier sell for the AHJs. And so it really solves a lot of the primary problems. And sort of icing on the cake, the unit itself is quite efficient. But the icing on the cake is it's able to quite effectively take advantage of the acceleration of the wind over a building. So if you've got a south-facing building, if you've got a building that's facing in the predominant wind area, I just came from a spot that had a south-facing predominant wind. But if you're facing the building into the wind, you can get a fairly significant acceleration. And so then, in addition to the base system being fairly efficient, you can get really a significant amount of energy off that acceleration.
That was so interesting. You've framed the benefits really well. I was looking at the website, and they almost look like the size of a refrigerator, or some sort of piece of HVAC equipment that you would mount on that face of the building that's closest to the wind. And I see why, from a permitting standpoint, from a noise vibration standpoint, it all makes sense. Are you collecting enough energy? I mean, is it cost effective? Here you are, a solar guy. I mean, you've been dealing with the cost effectiveness of solar systems for a while. Are these cost effective?
So the answer is yes. The thing that drew me to the business, and I think the thing that makes the business fundamentally exciting, is that the technology promises to generate plenty of power to offset its capital costs. And I ran the economics through sort of a fairly standard LCOE model, and it penciled out great. It competes quite well, not with sort of the best solar systems out there, but it performs, for example, extremely well with carports. It performs well financially compared to many rooftop systems. So it really is, I think, going to be a significant opportunity.
And no rare earth materials involved or anything. No. It's very basic, right?
It's really basic. It's almost embarrassingly basic, Ted. I came from a background of building solar modules, and solar modules have got these complex semiconductor physics going on, and this looks like HVAC components. It's
well, again, now let me just drill down a little bit. I'm just thinking. I read that this is good for flat commercial buildings, large rooftops. Is it? I think it's a super naive question. I mean, they're not going to be appropriate everywhere, right? There must be windier areas than others where you're focusing on.
Well, there's a whole bunch of considerations, Ted, and that's a great question. The first consideration is just fundamentally how much wind resource is there in the region. Yeah. So that's the first question. And so, fortunately, that information is very well understood. There's lots of maps, so we can definitely target the project development efforts around those regions. So that's the first question. This particular system is sensitive to wind direction. So we have about a 130-degree aperture through which we really generate significant amounts of power. But if the wind comes outside of that cone, then we really don't.
They're not swiveling around.
They're not swiveling around. They're bolted to the parapet of the building, right? They're fixed. So
Yeah.
that means that you really want to have an area with a windrows that has a very dominant direction. So that's the second criteria.
Yeah.
Um, the third criteria is you really want a building that has a face where you can install these that faces that dominant wind energy direction. So that's a key criteria. And then the
Mm-hmm.
last criteria is you don't want to have real dirty air. You don't want to have a lot of structure or tall trees, upwind of that. You want some space so that the wind that's hitting the building is in relatively good shape. And so that's sort of the fourth criteria. So when you take all those criteria into account, candidly, there's some significant, you know, attrition in the pipeline of opportunities, but there's still just a ton of buildings out there. We have no problem finding suitable buildings to put these systems on.
Or so, I mean, here in California, I mean, would they be suitable in Los Angeles, for instance?
We have not. So candidly, probably not great.
Right.
We probably not great. We've got. We're really focused. The main areas where we're getting traction are sort of in the dominant wind corridors in kind of the Central Plains areas. We get a lot of interest there, and then we're getting a lot of interest in Northern Europe. There's a lot of great wind resource in Northern Europe, and so we've got just a ton of opportunity there. And we're not ready for it, candidly, but we have a lot of really strong inbound interest from areas in the Middle East with strong wind resources, and quite a few areas in Asia. We've got some strong inbound interest from areas in Asia. But we're not planning on opening those markets anytime soon, but it's nonetheless very promising looking.
Where do you begin?
Well, that's a great question.
That's the purpose of your planning, I'm sure, at this point.
That's the purpose of the planning. Yeah, we're trying to scale the business up, and so right now we're really focused on where do we have great wind energy, so that we're deploying, in the highest performing areas first, candidly, and then secondly, where is the statutory environment most favorable to getting this kind of nascent technology, into the market. So we want to go someplace that is going to be relatively accommodating of startups, certifications and technology stack.
Mm-hmm. And then, of course, you want to offset a high rate, as high a rate as possible, right?
Yeah, candidly, actually, that's not the first criteria, because what we're really trying to do is to get momentum. But we definitely want to offset the high rates. And so, we were taking a close look at some of the countries in Europe where we've got some 25-30% industrial rates, and then some really strong wind resource as well. So there's certainly some northern European countries that look like they're just going to be fantastic. And quite candidly, the system pencils, in significantly lower wind resource areas, but we really want to start where we're able to get the technology proven and we're able to demonstrate its efficacy, without any question right away. So we're really focused on those areas.
Makes sense. Now, this was developed, am I right? It was developed was it Texas Tech by a grad student there from Denmark?
Yeah. Karsten Westergaard developed the technology. He's a long-time wind energy technologist, had been at Vestas, had led Vestas's R&D team in the U.S. For a while, and he spent a good part of his career, really both manufacturing and modeling aerodynamic systems for the wind energy business for large, what he calls big wind. And he started developing this idea a while back, and just ended up leaving Vestas and kind of committing himself full time and funded the early development just out of his own pocket.
Right.
And it brought on some angel investors and got some momentum. They went through about 6 rounds of prototypes and got some really interesting results. And we've got now, we're just on the cusp of really what we're calling our commercial pilot, which is really the sort of the first productive systems deployed into the built environment, not just sitting in a lab field somewhere.
Right. Where will this pilot be?
Well, I can't disclose that.
Oh, but I take in the States. I take it.
But yeah. So the goal is to deploy about quickly deploy 2 to 4 commercial pilots in the U.S., probably in the big wind states, and we're in conversations with potential customers for that right now. We've got. I must say, we do have one system. We have I think 6 systems that are deployed. They're not this generation of product, but we've got some sort of R&D systems that have been put on real commercial roofs. So just to pick one customer specifically, the Tractor Supply Corporation has just bent over backwards for us, and they've got some distribution facilities in Texas, and they have been very good to us, and they've given us pretty much unfettered access to their roof. We've got an R&D system up there that we're using to tune our performance. And so, we're expecting to continue to build great relationships like that with fantastic brands that really need this solution.
Good stuff. Did it take a while? And I'm still trying to get my head around why if you have a certain amount of wind coming out of a building, if you put a turbine there, it seems like you'd get a significant amount of power. But your system, you're funneling air through a venturi that creates creates a suction effect or something, and it's almost like you're using sort of the secondary effect of what's happening there, but that works out better in this case.
Well, okay, so to be fair, we're not trying to compete with big wind turbines, right? We're trying to solve a very specific problem, and that is what are the technical problems to solve to deploy wind energy into the built environment. So we're very focused on that narrow problem, and within that space, open-bladed turbines are problematic. They have all kinds of issues that really have prevented adoption.
That's right. If they were operating ideally, they would generate more than your system. Sure, certainly. Okay.
So this is not an improvement on that. This is a countermeasure to a host of secondary problems that prevent that open blade technology from really taking root in the built environment.
Right.
And so we take advantage of the fact that as wind accelerates, the static pressure drops, and we use that static pressure basically to pull wind energy through this impeller. And there are some performance advantages. So a significant amount, and I'm not a wind engineer, so I just play one on podcasts. But a significant amount of the losses that you get in an open-bladed system come from tip effects related to how the vortices form off the tip of the windmill as the blade is spinning. In an impeller system, you don't have any tip effects at all. So you've got a blade spinning inside of an enclosed housing. So it's fundamentally a more efficient generating solution. And so there are some actual efficiency pickups that we get because of that architecture. But at the system level, the efficiency is good. It's quite good, but it's not going to be at the level of a big wind turbine.
Right. And then is it fair to ask what one of these units costs and how many kW are they rated in kW then?
Yeah, they're rated in kW, and the way to think about that is the kW rating is really it's a rating on the inverter, more or less. And so if you're in a very high wind circumstance and the inverter is being pushed to its absolute limit, at some point the inverter needs to break the system, and start curtailing power because the inverter is simply just not rated for additional power. So that rating right now on our inverters is 5 kilowatts. The thing about the system is it doesn't perform at 5 kilowatts. Unlike a solar system, when you put a solar system on a flat roof and you've got a nameplate output, if you are in a great sun resource system, you're going to get quite close to that. In reality, our inverter is significantly oversized. The system performs, generally speaking, some fraction of that. But unlike a solar system, it can have a very high capacity factor. And so the kilowatt hours produced by the system are actually quite good.
Right. And you could end up with a lot of evening generation and nighttime generation.
Yeah, it just depends on the wind resource. So you could run it 24 hours if you had the wind resource for it.
I'm just thinking in sort of a macro sense, and I know here in California, the wind resources peaks out in San Gorgonio and Tehachapi early morning, and then in the early evening or late afternoon, early evening when the temperature differentials are the greatest, kind of when we need it the most in California. When after the solar goes to sleep, right, in the evening.
That's right, and so it's going to be complementary, and we certainly look forward to a time when we have this solution prevalent in the built environment. We can do a lot to the duck curve. I think we can make some significant improvements.
Yeah.
So I think it cohabitates very comfortably with solar.
Yeah. So how do you deal with requests then? I mean, I know you're all getting together. You're figuring out which region, which utilities, which, like you said, you got your screens for where it would be the ideal, and then you got all sorts of folks that are calling up probably and saying, "Hey, I've heard about this."
We totally do. It's actually, Ted, one of the biggest challenges that the sales team has to deal with is they get kind of a torrent of inbound interest.
Yeah.
So I just got an update. We have accumulated since we went live with this. We've accumulated 1,300 inbound inquiries, which for us just seems like a ton. And so what we do, the basic process is we begin sort of pre-qualifications with the customer, and then we want to move quite quickly to an initial sort of project qualification. And so we've built really a great tool for quickly vetting the wind resource in specific geographies. So it uses publicly available wind energy, makes a map using Google Earth. It allows us to display on the map wind roses. It estimates what the wind rose is going to be for a specific site. It estimates, based on the basic parameters of the building and the topology of the region, what we think the production on that site would be. And so we can dump in a portfolio of 300 buildings in a spreadsheet, run a script, and it'll run it through this tool, and it'll spit out, okay, we recommend this subset of those as being worthy of additional analysis. And so then we go into that subset, and we really kind of tear into the exact topology of the region. Are there trees? What other structures are built? And we do kind of a desktop review.
Yep.
Once we get through that, and we've got a portfolio of sites for a given customer that we're thinking is a great fit, then the next step is we go out and we deploy wind masts. And so we work with the customer to get a wind mast set up on each of their locations that they're interested in. And we do about a 3-month actual data collection exercise to really understand what's there. And then at the end of that process is when we really move to the concrete contract and construction project plan.
Yep. Boy, that's great. And of course, at some point, somebody's checking the structural, I guess, integrity of the facility, right?
Yeah, there's actually a tremendous amount of diligence that we have to do, and we do that during that period that we're collecting the wind energy.
And so is that an issue with your systems in terms of weight?
It is. Anytime you put something on the roof, it's always an issue. You need to know what's on the roof. You need to know how it's built, what it can accommodate. The system isn't light, candidly, but neither are roofs built to withstand, way more load than they were than just holding themselves up. So there's always kind of a question of diligencing exactly how the roof was built, and getting a structural engineer involved and looking at the loads and the truss. And very often the roof is built, and then someone will come in and hang loads for their factory underneath that roof and load it all down. And so, you can get into a situation where these roofs are overbuilt already, even when you step on the site. And so you have to diligence every single roof. And so this is no different. That's the case for solar, and it's certainly the case for them.
Sure. And you might place one of these units every 5 or 10 feet along a
they're
roof
bigger
line?
than you were suggesting. Yeah, they're 9. The current version that we're deploying is, I think, 9 by 14 feet, if I'm not mistaken.
Oh, okay.
And there's an aerodynamically optimum spacing. And candidly, I don't think we know as much about that aerodynamically optimum spacing as we'd like. And so, but I think, rough order of magnitude, it's a few system widths. So for a 14-foot system, you might be looking at 20 or 30 feet minimum between systems. And, we're still, I think we have a plan to study that in more detail. And that's one of the purposes of these initial commercial pilots, is to study that particular problem, on a field in Denmark or on a field in Texas. It's very difficult to study that, the interactions between the building and multiple units on the parapet.
Right. But you envision, I mean, I know it's going to always vary, but you envision that clients would have dozens of these units, I take it, right?
Yeah, ultimately dozens of these units. We think, we've laid out some buildings for some of our clients, and, with upwards of 30, or even in one case, I heard nearly 50 units. So they, we imagine putting a lot of these on the roof.
Yep.
Yeah.
We've only got a couple more minutes. Grew up where, Mark?
Well, I grew up in California. I grew up in Los Altos. Yeah, Los Altos, California. Wonderful place.
And you ended up going to work for SunPower. I'm fast forwarding, of course.
Yeah,
you got you got your engineering degrees, I saw, from very prestigious institutions like Stanford and University of Michigan.
I was very fortunate. Yes.
Yeah.
And then one way or another, I ended up at SunPower, and I ended up. The story there is an interesting one. I met Marty Neese, the chief operating officer at the time, and one thing led to another. I wasn't intending to work at SunPower, actually. I wasn't intending to work in the renewable energy space, but Marty invited me to come to SunPower, and it was just awesome. I loved it. I wasn't a renewable energy guy. I was a computer and car guy coming into that. And Marty gave me an opportunity to run SunPower's global solar module manufacturing organization, and I just thought I had died and gone to heaven. I had so much fun, and I loved the mission of the industry. I loved the scale and the culture at SunPower. I loved that. I loved the intensity of the manufacturing environment. But the thing that really drew me in was just how awesome the mission of the industry was, and I just fell in love with it.
Yeah. And then I don't know which happened first. You were at Complete Solaria, and then also at Borrego, where you dramatically increased the size of Borrego. And congratulations on that.
That was really fun. I'll tell you, Ted, that was the most fun I've ever had working at Borrego. I had a great time at SunPower, I really did. But working at Borrego, so Mike Hall was the CEO at Borrego and one of the founders, and he hired me. And for your listeners that don't know Borrego in 2017 was a significant but very regional C&I EPC serving the solar space. And so we built,
largely in Southern California, right?
Well, all throughout California and then Massachusetts, basically two places. So we were doing sort of 2 to 5 megawatt systems in Massachusetts, and then we were doing mostly rooftops and carports in California.
Yeah.
And Mike hired me. I won't go into all the details, but we had together we fashioned a plan to really turbocharge that business, and we had a tremendous time. But we grew that business, and it ended up becoming, according to Woods Mackenzie, the number one C&I developer and EPC in the United States by a factor of 2, and it was just such a joy to be part of that team and to get to be part of that. It was super fun.
What an exciting time! Well, quadrupling revenues, tripling market share. I mean, those are great indicators, and obviously that's why Aeromine is excited to have you on board, right?
Well, I tell you what, I am actually. People ask me, well, gee, you just started at this startup, and you've gone from running $1 billion P&L to a startup. Like, what's that like? And I'm just so thrilled to be able to tell them, what, I just feel like I'm in exactly the right place. And let me tell you why, Ted, since you bring it up. I've got this background in hardware, so I spent most of my career manufacturing stuff. And then at SunPower, manufacturing stuff and bringing stuff to market. So I got to, SunPower's entire product portfolio, I had a significant hand in bringing that to market. So I've got this sort of 1 foot firmly rooted in bringing stuff to market and all the grimbly operational details of that. But then I also was given this fantastic opportunity by Mike and then the good folks at Complete Solaria to get really involved in the construction side of the business and the project development side of the business. And so as I think about Aeromine, Aeromine's got it's got to do exactly the same things. It's got to build stuff. We've got to get this Aeromine supply chain going. And then we've got to become a developer, and we've got to develop projects and sites. And then we've got to be a contractor one way or another. We've got to make sure operationally these things get built. And the good Lord has given me the opportunity to work on all 3 of those things. So I'm super excited about this.
How exciting! How great! Good for you. Good for you. Good for Aeromine. Good for the globe as we roll out another clean energy solution. Right. Thanks so much for being on the podcast, Mark.
Well, thank you so much, Ted. Thanks for your work in promoting renewable energy, and I'm just thrilled to be here talking with you. So thank you.
Good. Take care.
All right. Take care.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.